Okay, so this video, I have shown you that, guys, this before. I know I have, but I'm going to do it again just to reiterate the importance of it. So this is going to be a video about why IAT testing is unreliable when the patient's red blood cells are being tested and have a positive DAT result. So why IAT testing is unreliable when the patient's red blood cells are being tested and have a positive DAT. That's what we're going to be talking about. So when we talk about a patient having a positive DAT, we are referring to their red cells being previously coated with an antibody in vivo. Inside their body. They are already being coated inside the body. And that makes IAT testing unreliable because we don't know if the anti-human globulin is binding to the antibody that we added to the reaction or if it's binding to the previously coated antibody. So we can't rely on the test. So if we're doing IAT testing when the patient's red blood cells are being tested and have a positive DAT, we can't actually do the IAT test. We can do the IAT test even if a patient's red blood cells have a positive DAT if we're testing the plasma. So we do IAT testing with the antibody screen. We bring it through to IAT with the 3 screening cells. And we use the patient's plasma. That's okay, even if the patient's red cells have a positive DAT. As long as we're using the plasma portion, this positive DAT will not affect the IAT results. But if we're using the patient's red cells in the IAT test, not the plasma, but the patient's red cells that have the positive DAT, then we can't rely on the IAT result. And this is why. So we take the tube of blood and it has the patient's packed red cells there, which we've determined are already have the positive DAT. So there's an antibody coating in vivo. In the test tube from their arm, it's already coating. We did not put it there. And what's the IAT test? It's the indirect method. So we pull this from the patient's arm, we spin it down, red cells on the top, or red cells on the bottom, plasma on the top. We have plasma up here. And then we do our DAT test. The DAT test is direct. So we take the patient's red cells that are coated with an antibody. We don't know that yet. We don't incubate. It's not indirect. It's just direct. Direct red cells. Are they coated? Well, let's find out. We're going to wash away any unbound, keep the bound, and add anti-human globulin. Anti-human globulin will react with these previously coating antibodies and give us a positive result. So now our DAT is positive. So we know that. Okay. So that was the direct. Now, if we had to do an indirect test with the patient's red cells, this is when we would take the patient's red cells and do an indirect test to see which antigens were coating the red blood cell. So for example, in the lecture slide that I was giving you about anti-D, if we have a tube of blood, a reaction tube that we take the patient's red cells with, and we want to see which antigens are on the red cell surface, well, if they're previously coated with an antibody, that's going to cause problems at the IAT phase because they're previously coated. IAT requires an incubation phase and the addition of an antibody. So when we're doing the weak D test, we are adding to the patient's red cells commercially prepared anti-D reagent. It's anti-sera. That's what we're adding to the red cells to see if there's any D antigens on the red cell surface. We're adding anti-D, anti-sera to see if there's D antigens on the red cell surface. So when we add those D antigens, if there are little D antigens, sorry, I said antigens, I meant to say antibodies there. We add the anti-D antibody. If there are any little D antigens on the red cell surface, that's fine. This anti-D will find it and they'll bind to it. Even though these little blue antibodies are already coating the red cells, it won't interfere with the anti-D binding to the D antigens. They'll still find it, and that's fine. But when we go through, so we have red cells previously coated with an antibody in vivo. Now we're adding more IgG, anti-D, to the tube, and it's going to bind to the little D antigens, but we can't see this. We have to enhance it by incubating at 37 degrees to allow them to bind. And then we have to, we then wash away unbound. And then we have to add anti-IgG. The problem here, this is where the whole problem comes up. If this tube has little D antigens on it, oh, not little, I shouldn't say little d. That sounds like I'm saying this. I'm not saying that. If they have D antigens on them, the D and a previously coding antibody of an IgG class that happened just to be coding there, our anti-D that we added here, this anti-D, is going to bind to the D antigens, because that's what it does at 37 degrees. And this is weak D testing. We went all the way through to IAT. This is weak D testing. So it did bind to the anti-D, but what's the step here? We have to add anti-IgG. Well, anti-IgG is going to bind to anything. It's going to bind to any and all IgG antibodies that are in that tube. Well, there's two kinds in there right now. We have the previously coding antibody, and we have the anti-D that we added. Anti-IgG doesn't care. It's going to bind to all of them. But we can't see these two distinct antibodies. We don't know that there's two distinct antibodies. We know that there's one because we already did the DAT. But when we add the second antibody, when this agglutinates, we don't know if it's agglutinating this one this one, or both. So when we see agglutination there and we see a positive reaction, the positive reaction is being caused definitely by this antibody that was previously coding. That means even if it's agglutinating this one, we can't rely on it because we don't know if it's this one or if it's also this one. And this one's going to agglutinate only if there's D antigens there. And the whole point of this test is to see if D antigens are there. But if this one is giving us a false positive, we can't rely on whether or not that's actually binding. So in a comparison, this would be a true positive because I'm showing you in this picture that there are D antigens present. This person, these red cells are Rh positive, but we can't rely on the test because we don't actually get to see whether or not the antigens are there. We just observe agglutination. But this agglutination is being caused by two antibodies, and I can't tell which one it is at this point. It's not reliable because that other previously existing antibody is interfering with my positive reaction. So to compare that, say we had an Rh negative individual with the same previously coding antibody. At this phase, the same phase, we're going to have the red cells that are Rh negative now. This one was Rh positive, but unreliable. And this one's Rh negative. Oh, sorry, you can't see that. You can see my test tube, but that's about it. There. That one's Rh negative. So there are no D antigens on this one. But we don't know that. We have to add our anti-D to see if it's there or not. But these red cells are previously coded in vivo, like up there, the blue. They're previously coded. So now when we add our anti-D here, at this 37 phase, we're going to add anti-D. But there are no D antigens. This is an Rh negative person. There are no D antigens for that anti-D to bind to. So at 37 degrees, the antibodies are going to be in the tube, but they're not going to bind because there are no antigens for it to bind to. We don't know that until we add anti-human globulin. And we're expecting, if that's the case, we're expecting the anti-human globulin, the anti-IgG, not to react with anything because I just told you that there are no D antigens there. So sensitization would never have occurred. The anti-D that we added will never bind to the red cell surface, and it will then get washed away in the wash step, and then it'll be gone. So now we've done the wash step. The anti-human globulin, or the anti-D, is now gone. It got washed away because it never had anything to bind to. However, when we add the anti-human globulin at this phase, because it's IAT, when we add our anti-human globulin, it's still going to bind to these original, previously coded antibodies. So we're still going to see a positive reaction here because it's binding to this antibody. So this is still going to come up positive, which is what this test was positive. They were both positive. When the anti-D truly did bind to the D antigens, we saw a positive result. When the anti-D did not bind to the red cells, to the antigen, and got washed away, we still saw a positive result. This should have been negative. This test should have been negative because the anti-D got washed away and there shouldn't be anything there for it to bind to. But because there was already an there was already an IgG antibody in blue coding in vivo, it's still there, it didn't get washed away, and the anti-IgG picked it up here, and we still had a positive result. But under normal circumstances with a negative DAT, if the antibody was never coding, under normal circumstances where results could be reliable, this should have come up negative because there should not have been any anti-D left over. It should have been washed away. So this is why IAT testing is unreliable when the patient's red blood cells are being tested. They're being tested here. They're being tested for an antigen, the D antigen, but they have a positive DAT already. Then this result is not reliable. We can't do it. I don't actually know. I mean, I'm showing you in the picture that you can see that the D antigens are there or they're not there. But in the real world, we don't have this beautiful diagram to show us the tiny little antigens that are on the red cells or not there. All we see is agglutination. And our agglutination is going to be unreliable. It's going to be false positive because we have that interfering previously coding antibody that's going to make the anti-IgG react with. Okay? So that's why we can't do IAT testing on a patient's red cells if the red cells are being tested and they have a positive DAT. We can do immediate spin because we're not adding anti-human globulin. If this was just basic immediate spin and we stopped here, we can add anti-D, and if it's the good stuff that's commercially prepared, it's bigger and it can bind at immediate spin, it's going to find the little D, or it's going to find the D antigens, and it will bind to them and it will agglutinate. These little previously coding ones are not going to interfere at immediate spin. As long as we add the anti-D, it will agglutinate the red cells. But the minute we start bringing it through to IAT and the minute we introduce anti-human globulin, that's when it starts to interfere. It's not subjective. It will bind to anything. We can't tell which antibody it's actually binding to. Is it the one that we put there and we were looking for a result? Or is it one that was already there and causing the reaction? We don't know. So we can't actually perform the test. This is a test that is not allowed to be done if the DAT was positive and we're testing the patient's red cells. Now, if we do IAT testing and we're using the plasma from this same person who has the positive DAT, if we use the plasma and we use reagent red cells, those reagent red cells are not coated with anything. We're using the plasma, and we can add the plasma to the tube to reagent red cells that have no previously coated antibody. And so the plasma is safe to use from this individual with this coated red cell because we're using the plasma portion, which is unaffected by this positive DAT. And that's really important to understand too. Just because the patient has a positive DAT doesn't mean we can't use the plasma at IAT. It just means we can't use the patient's red cells at IAT. So two different, same method, but two different samples being used. We're either using the plasma or the red cells. Red cells are unreliable if the DAT's positive. And that's why. So this is the weak D test. We had to go from immediate spin. It may have come up negative because these are weak D antigens. So we have to bring it through to the IAT phase, which means incubate, wash, and add anti-human globulin. And the minute we add that extra antibody and we're bringing it through to IAT, and we add this anti-human globulin, that's what's going to cause the problem with the conflict. Is it binding to this antibody or is it binding to this antibody? We don't know because it still came up positive here, even though that black antibody got washed away. We still had a positive reaction. And that would be a false negative for the D result. So that example that I showed you where the mom, let's see if I can get rid of this. Where the mom was Rh negative, we were trying to decide whether or not she should receive RhoGAM. Remember? She was Rh negative and the baby was Rh negative, but the baby had a positive DAT. We're doing antigen testing because we want to see if the D antigen is present on the red cells. So we're doing antigen testing. So if, like I had said, if the mom was Rh negative and the baby was Rh negative, but had a positive DAT, does this mom need RhoGAM? Rh negative baby with a positive DAT means we can't do weak D. Because weak D requires the IAT phase with patient red cells. And if we have to do weak D with the patient red cells who have a positive DAT, then our weak D test is going to be unreliable. So we can't truly say that this baby is truly, truly, truly Rh negative because we can't do the weak D test. So if we can't truly say that this baby's Rh negative, we have to give the mom RhoGAM to err on the side of caution because we can't guarantee this result. And we can't actually do the test and give them the proper result. So we have to just treat them as if they were Rh, like weak D positive, because it's safer than not giving the RhoGAM. Because what if there were little D antigens on the red cells? What if this baby did have D antigens and they were in the form of the weak D, but could still elicit an immune response in the mom and could still give her the ability to produce a true anti-D? And we didn't, even though we couldn't do the weak D testing and we didn't know it was there, what if that weak D was there and did cause a problem with the mom and we didn't give her RhoGAM? We'd screw it up. So this is really, really critical to understand. So hopefully this helped. Hopefully this gave you, I did show you this before in class, but I once you see it a second, a third, a fourth time, and it kind of all comes back together and ties together, hopefully that helps you guys understand better. But it's really important to understand that concept. Okay? All right.